So today we're going to finish Unit 4 in quotes because, as I explained in our last video, these two topics that we've talked about in our last two videos, the last one and this one, are actually part of what would be in the curriculum as Unit 5, which is data. However, they tie nicely into our linear functions unit, so that's why we've pulled them over there. So today we're going to finish up our discussion of scatter plots by talking about how to find the equation of the trend line. So in our last video, we learned how to make a scatter plot, we learned how to draw the trend line, and we understood the idea of positive, negative, and no correlation. Today, we're going to determine the equation. We're going to write the equation of the trend line to use that to make predictions. And we're going to introduce another idea with correlation called the correlation coefficient. The correlation coefficient, we will not be doing the math to find it out. We will not be doing that statistical work. We will let technology do that, but we just need to understand what the number means. So let's go forward first and talk about writing the equation of the trend lines. So you might remember this scatter plot from our last video. It's, the more you study, the higher your grade goes up. You might remember that one. So the question is, how can we write the equation of this line to represent the trend shown by this particular scatter plot? So the first thing you're going to do is you're going to find 2 points on the line that are the 2 points that are on your line, not data points, but on the red line that are as close to the crosshairs as possible. So, the four corners. So I'm going to take a little ring here and I'm going to go up my line and I'm looking for sort of a point on the line. If you'll notice, that one isn't so bad. I'm going to get another one. I need 2 points. And I'm going to go up looking again and look right here. Boy, that one's right in the center. Now, neither of those points is a data point, but those are the 2 points I'm going to use. So the first thing we do is on our trend line, find 2 points that we can easily name the coordinates. So this is 4, 70 and 10, 90. So pick 2 points on the trend line, and we're going to calculate the slope and use the point slope form. Basically, this is a case 3 problem where we get 2 points, we're going to find the slope, and then pick one of the points with the slope and put it in point slope form, and voila, we will have the equation. So when we go to write our equation, remember we're always going to define our variable. So I'm going to use X for the hours studying, and Y is going to be our grade percentage. And that's always easy to get off of a graph because of the labels. I already ringed my 2 points, and I just named them a second ago. So 4, 70 and 10, 90. To find the slope, I'm going to take Y minus Y. Oh, by the way, it's rate of change, and since it's a real-world problem, but rate of change is just slope, basically, in a real-world problem with units. So I'm going to take Y minus Y over X minus X, which would give me 20 over 6, and because it's a real-world problem, I'm going to divide that out to get an approximate unit rate. In this case, it's about 3.3. So I'm going to use the point slope, Y minus Y coordinate, and I chose to do this point, equals slope times X minus the X coordinate. Now, I didn't write it out here, but remember, then you would do distributive property and then add 90, and you get your slope-intercept form, and it's Y equals 3.3X plus 57. Now, notice there's a question over here. Is there an easier way to get that y-intercept to 57? And off of this graph, look right there, you can kind of, see that that's about 57. So in this case, we could have just calculated the slope, kind of like a case 1 problem, come up off the graph and gotten the y-intercept. But boy, do I need you all to listen to me right now. Are you all listening? Okay. If you're going to do it that second way and grab the y-intercept off the graph, there cannot be a break in the graph on the x-axis, number 1. And if there is a break in the graph on the y-axis, your line has to hit above it. Otherwise, what you are looking at is not the y-intercept. And that's almost easier to understand when you see a case where there are breaks, which we will do in a second. So bottom line is, this method of picking 2 points and using the point slope form will always be accurate. But if you're going to try to pull off the y-intercept, you better be real careful looking at the graph and checking out if there are breaks in the graph. So here is an example. You'll see the break in the graph on the y-axis, and notice my trend line is going to hit above it. So that will be a legitimate y-intercept. If that trend line, when I drew it, hit in the middle of the break or below it, it would not be valid. Okay, we'll talk more about that as we go forward. So I'm going to do the method with the 2 points just to go through that with you again. So again, we're going to be writing an equation. We're going to define our variables. What is this? So animal longevity. So basically what I've got on the x-axis is a given animal's average lifespan. So this animal right here is, say, about 8 years on average, and the longest ever, the maximum lifespan ever of that animal was 20 years. And then as you come out here, you're seeing like an average of 40, and up here, 78 maximum. And basically what happens in a scatter plot is when you plot that point, you lose who it is. I don't know what animal this is without looking at my original data, but I'm more interested in just seeing sort of a trend here that's comparing a maximum lifespan to an average lifespan of an animal. So just remember that once you plot the points, you kind of lose who it is. I'm going to guess out here we're looking at animals like elephants, that live a longer time. I don't even think our what are those large, the really big tortoise. I think they're even further out here. But anyway, just to let you know, that's the case with a scatter plot. So I use my labels. So, Y is going to be the maximum age in years, and X is going to be the average age in years. I plot my points, I draw my trend line, which was the last video. Now I ride up there, and you see I've got 2 points circled. They look like they were data points. They don't have to be. What they have to be is in the 4 corners. So they're sitting in a horizontal vertical corner, basically. Now, once I have those 15, 40, and 35, 70, I write my 2 points. And I do need to see this so I can kind of make sure you're doing everything right. So make sure you always write your points. Now I'm going to calculate the slope, the rate of change. I'm going to take y minus y over x minus x, and I end up with 30 over 20. Oh, by the way, 3 over 2, 3 divided by 2, it's 1.5. I'm going to use my point slope form. Y minus a y equals the slope times x minus the x. I'm going to do my distributive property, add the 40, and I get my slope intercept. So now that we understand the process, let's talk about what benefit this would be. A minute ago, I explained about those giant tortoise that I think they live even longer than this. They would be off the graph. So here, what I'm allowed to do, as you could guess, is I could put in any average age to get any maximum. So if I fill in an X value, and let's say that giant tortoise on average lives to be 60 years, and I take 1.5 times 60 and add the 17.5, that would be my prediction of what the maximum year would be. I also could put in a maximum year and solve the equation for X to get the average. So once I have the equation, I can go past the graph. So, if I wanted to know, how about a 30 average, I can look right up here. It looks to be about a 61 maximum. But what happens when you're off the graph? And that's what they're doing with things like temperature change, or what's going to happen to a given animal population that's dying off or increasing, 50 years in the future. They're using an equation to make that prediction. So here is another one, the production workers' average hourly earnings. And we are going to, again, make kind of an equation from this. Now, notice in blue here, points do not need to be from the original data. So I am riding up this trend line, trying to find the 2 lines that lie in the crosshairs. And, there could be more than 2. By the way, The further apart they are, the more accurate you are too. There's less wiggle room, but sometimes, you can't always find those. So, I'm going to use the 0. Now you got to be careful here on your scale. They're going by 0.25. So this is money. So a quarter, 25 cents, 50 cents, 75, 12. So this would be at 0 years since 2000, which would be the year 2000. So right here is the year 2000. So 0 years, see right there, would be 1150. And then 6 years later, that would be 2006, we're looking at $14.25. So we're looking at how salary is changing. In this case, hourly earnings is changing for production workers. So back in 2000, they were making about $11.50 an hour. And in 2006, it had increased to $14.25. So now what I want to do is make that equation. So I would calculate the slope, y minus y, for x minus x, divide it, use my point slope, right? And then I could go to my y equals mx plus b. But my question is, could I go directly to y equals mx plus b once I have the slope here? So you're going to look for the break. And you'll notice that we are starting at 0, in this case, the year 2000, which is fine. The break is below, so I can just use that 1150 as my y once I calculate the slope. Next up, what does the slope mean? What is the 0.46 in terms of this problem? And what it's saying is that there is an increase by 46 cents every year. Oops, have a little break there. Every year since 2000. So every year, 46 more cents per hour. Now, what is the y-intercept? We already said that was the 1150. And what is that? That would have been the amount of money that they were earning in 2000. So there's our equation. And now maybe we want to make a prediction of, what's going to happen in 2020. So if we wanted to know what would happen in 2020, look here. What number would we put in for x? It would be 20 to be 20 years plus 2000. You'd multiply it times 0.46 and add 1150. And that would give you a prediction of what happens in the year, well, now basically, if wage increase stayed the same. And it looks like it would be, according to my calculations, kind of quickly here, about $20.70. So, now if we predict the hourly earnings for 2010, you just put the 10 in there, add it to the 1150. That 10 times 0.46 would be $4.60, add it to 1150. And back in 2010, it would have been about $16.10. Does this keep growing? Is this linear? Or are there events like possibly the pandemic, possibly other things that have happened that could slow it down or potentially speed it up? But right now, if this trend continues, it would be $16.10 in 2010 and $20.70 this year. Is this the best line for the data? That's our question, right? We kind of drew that in. I drew it in for you. Now, the bottom line is that a calculator or a computer does a perfect job of calculating it. They do the statistical analysis that fits that line in perfectly. So we are going to learn about that. But today we're going to just learn about something that will be generated by technology. We're not going to learn the math to get the number ourselves, but we just have to understand what the number means when we get it from, let's say a graphing calculator. And it's called correlation coefficient. So there is a thing called the correlation coefficient. Its abbreviation is R. I don't know. It's R. The calculator will give you an R squared and an R. We're looking at the R. That's the correlation coefficient. And it tells how closely the equation of the line of best fit models the data. So how tight are those points to that trend line? So a stronger correlation, right? What kind of number would that look like versus a weaker correlation? So the value of R has to be greater than or equal to -1 and less than or equal to 1. So there'll never be a correlation coefficient of 2 or negative 1.10 or 100. It has to be in between the numbers -1 and 1 inclusively. Basically, a perfect positive correlation, if all your points fell on a positively sloped line, every single one, perfect positive correlation, the correlation coefficient would be 1. And for a negative sloped line, if all your data points fell on a perfect negative sloped line, the correlation coefficient would be -1. The closer you get to 0, the more spread out the points are. So if you had a point 0.8, it's still going to be a positive correlation, but the points are more spread. If you have a negative 0.85, it'll be a negative slope line and they're more spread. And if you have something like 0.3, 0.2, it's getting really scattered, hard to draw those lines in. Down here, I've again said that an R equals 1 would be perfect positive slope for a correlation coefficient and -1 for the negative slope for the perfect negative slope correlation. Okay, so let's just say, and when you come into class, I have a generator that we can run just to make predictions, but I want you to look at this one right now, and what would a good estimate for the correlation coefficient for this data be? So did you say +1? So see right here what the program I'm going to run when you're in class is going to show you. It's going to show you the line, and it's going to give you the correlation coefficient. Now, don't get these two mixed up. That's the slope. That's the correlation coefficient. That's the y-intercept, basically. This is just saying that they're all lying on a perfect positive slope line. Okay, so now try this one. What do you think would be a good estimate for the correlation coefficient of this data? Now, we know it's not going to be +1. How close do you think this would be? Well, when I ran it, it was at 0.86. How did you do? Okay, so this is a 0.86. Take a good look at that to see the spread. This data correlates positively to this trend line, 0.86, okay? Let's look at another one. Ooh, what about this one? What would be a good estimate of the correlation coefficient for this data? What do you think? And see how close to 0 it is. Like if it tries to draw a trend line and it's putting a horizontal line. I mean, there is no trend line, to be honest, that you could draw in here. And again, notice that when we run this, it's not only giving me the correlation coefficient, it's giving me the trend lines equation. I mean, how great is that, right? So anyway, you can see that, it's trying. It's a bad correlation, though, to this trend line. I wouldn't want to make predictions off of this. I'd lose my job. Okay, how about this one? What would a good estimate, do you think, for this one be? Now, other than the perfect one that we started off with, this is the one that has been the tightest to the trend line. And also this one flipped that it was negative. Did you catch that? So if we run this, it's close to that -1. It's a -0.98. Its slope, its y-intercept, I would trust this trend line to make predictions because look at that, very close to the -1. So that's just giving you an idea of how to write the equation of a trend line, what to kind of keep an eye out. We can use it to make predictions into the future by substituting for X or Y, depending on what we're looking for. And also, depending on how tightly the data is to that trend line, we can feel confident, less confident, really super confident on our predictions based on how tightly that data does correlate to the trend line. So when you come into class, we'll talk again about this idea and see it kind of live in action. But in the meantime, your job now is to not just draw scatter plots, but to draw the trend line and find the equation of the trend line. The process is basically to pick 2 points that are in the crosshairs on the line. They don't even have to be data points. Get their coordinates and calculate the slope. The next step really depends on the graph. Can you use the estimate of the y-intercept? Well, that depends on breaks in the graph. And if you're unsure, don't. Use one of the points with your slope in the point slope form and do your distributive property, move your constant to get your slope intercept form like we've been doing quite a bit. That method always works, but you have to be careful estimating the y-intercept off the graph. If there's a break in the x, it's a no-go, and you have to watch the break in the y. If the trend line hits above it, you're good. If it hits below it, you're not. So any of that confusing, go with the point slope. So today we are really taking our linear functions and applying them. I mean, scientists do this all the time. Business people to make predictions in the economy do this all the time. Our next step will be to use technology to come up with those equations. So that will be fun for us, something different. So guys, get ready to do some scatter plots and make some equations of trend lines, and I will see you soon. Have a great day.